we decided to talk to the Vatican astronomer, and we'll do that a little bit later on. The Pope is visiting the U.S., so this is the kind of event that unites the world, seeing this. After all, it's Earth, it's the moon, it's our planet, and so much of the world is watching this at the same time. It's really a unifying thing. We're all seeing it, and again, I'll emphasize it, we're all seeing the same thing. As long as you have the moon in your sky right now, you're seeing the exact same part of the eclipse as everybody else. The only difference is that if you happen to be standing on your head, if you're in South America, in Brazil, let's say, where the eclipse is underway, although we understand from some of our Brazil friends that it's cloudy in at least parts of Brazil. But if you're in the clear, you'll see the moon at a different orientation because you're, of course, upside down relative to people here in the northern hemisphere. So that's the only difference. But the moon, other than that, the stage of the eclipse will be identical. And as we approach totality, we want to bring back our friend Scott from the Weather Network. This is Canada's equivalent of the Weather Channel in the United States. And Scott is an expert not just on meteorology. He's been keeping it in check and hopefully keeping the clouds away, when he's doing a good job of that for most of us. But Scott, we're also going to talk about these odd so-called edge effects caused by the fact that the redness is not uniform. It's odd, it's uneven, it's caused by our atmosphere. What's up with that? What's going on here?
Well, basically, the darkest part of the atmosphere, at least when you're looking at it edge on, is the lowest part, the troposphere, which is where most of our weather occurs. And if you look at this edge on, like, say, from the International Space Station, and their views of it, you can see this quite often, is that it's red at the bottom, and then there's a sort of a whitish pink layer in the middle, and then it goes off to blue at the top. And exactly, right there on the screen. So that's a picture of the Space Shuttle Endeavour from, I believe, 2007, taken from the International Space Station. And you can see the layers very clearly there. So that's the orangish-red troposphere at the bottom. Then you have the stratosphere in the middle and the mesosphere above that on top with blue. Now, the blue seems to mainly come from the fact that ozone absorbs specific wavelengths of light. And so it will pick out the reds, and so you'll only get the blue coming through when you're looking at it edge on like that. And as the light filters through the atmosphere, because the globe is curved, this acts like a lens, and all of that light gets beamed into the umbra, because the umbra itself is just a dark blank patch of light because the Earth is physically blocking the sun. But because of this focusing, the lens of the atmosphere focuses all that light, the different stratified layers of color, into the umbra. And the very center of it turns into a big circle of reddish-orange, coppery color, as you mentioned. And that's what we mostly see when we see a full total lunar eclipse, is that red. And as it enters the umbra and it leaves the umbra, sometimes you can catch that bluish tinge from the ozone absorption. And it's not often. It's hard to pick it out. There are pictures on the internet that people have seen that have posted up. But yeah, this creates sort of almost like a banding around the edges of the umbra of these other colors. And if you can watch really closely, if you can get a really close picture of it, you can see that.
Okay, so for our listeners, let's translate that. Umbra means Earth's dark part of the shadow. That's the part of our shadow where no sunlight is hitting the moon. And what Scott is telling us is that our atmosphere is being bent, refracted onto the moon. Actually, what we're getting on the moon, the reddish color, is really the combination of all of Earth's sunrises and sunsets. Very lovely, poetic idea being combined into a single kind of light. And the uneven color, as he's explaining, is due to these effects. Now, as the eclipse reaches its total part, and we only have 4 minutes to go before that happens, either look outside or join us with our many feed partners and our main telescope in the Canary Islands and take a look at the color of the moon. Note how uneven It is, and this is what Scott is talking about, these different parts of the atmosphere that are throwing light onto the moon. Let's see if we can see any. He said that there's occasions when it's blue. I've never seen that in 50 years of looking at the moon. Honestly speaking, I don't think we're going to see any blue. I think any photographs of that, the web, you can show photographs of a hippopotamus flying on the web. So I wouldn't trust any colors. But let us be the observers and decide for ourselves without bias. Let's look on the moon and see what colors we see. Now, is it really the color of blood? The media is calling this a blood moon. I think you'd have to go to the emergency room if your blood ever turned this color. Scott, have you ever gotten a cut and seen your blood turn this color?
No, I haven't. It's a little bit darker than that, a lot more reddish than that coppery orangish tinge.
Good. So that's right,
Yeah.
coppery, orange, maybe yellows, there's some white there. And when we reach totality, that's 3 minutes away now. Right now we're still seeing sunlight hitting one edge of the moon. And you can look for yourself when you're outside. This looks so weird. It doesn't look like any kind of lunar phase. It doesn't look like a normal crescent moon. It looks like a little spot of sunlight, and all the rest of the moon is uneven because it's getting different degrees of depth into the umbra. The moon, in fact, in this particular eclipse, the moon is not passing centrally into Earth's shadow, but will be on the south edge of the shadow. So we expect, and correct me if I'm wrong here, Scott, that the top of the moon, the northern edge of the moon, will be the darkest. That'll be most centrally in the umbra. The bottom should be the lightest, maybe yellow, maybe different colors. Plus, it's going to change as the eclipse goes on, because once the moon is fully in our shadow, it's going to stay there for, I think, an hour and 13 minutes. And it's going to start 2 minutes from now. So why don't you help guide us a little bit on these final 2 minutes of sunlight? What are you seeing now